Yeah. So in this session, we will continue with the OOPS concept. So previously, we had discussed about classes and objects, inheritance, and polymorphism. Now we have one more concept, like few more concepts are left, which is abstraction. Okay. So let's discuss the abstraction first. So let's suppose you are creating an application for any banking website. Okay. So let's assume that yeah, you are creating an application for the website, for the banking website. So we have a class named bank, bank app. Okay. Now inside bank app, this is a my class. I can put anything inside my bank app. Okay. Now let's say you are creating two more classes which will inherit from the bank app, which is your bank main application. Bank app is your main application. Inside bank app, let's say we want to use this banking application on the web, on the website as a website also, and I just wanted to use this create application which can also run on mobile platform. Okay. Now inside my banking application, I'm just configuring the database, like I'm connecting with the database. So this is my function, like my method inside my class bank app. Okay. Now, this web app is like the same application but running on the website. Same as mobile application is another banking app but running on the mobile app. Which means banking app is like a main application and web app is a child class of the bank app. Same as mobile app is the child class of bank app. So now web application wanted to inherit some features, we can some methods from the bank app. Let's say database. Now website will also run a banking application, right? Now bank application, which is running on the website, which is web app, will connect to database. So here I am writing a database, let's say database configuration code, where my web application is where my banking application is connecting with the database. Let's see. Now this web app is a child class of the bank app. Let's say. Now web app wanted to access the database, like database method from the class bank app to its own class. Okay. Same as mobile app is also wanted to access. Mobile app is also a child class of the bank app. Now mobile app is also wanted to access the database method within its class. Okay, that is simple. That is an inheritance. So let me code it for better clarity. So let's say we are creating a class with the name of bank app. Okay, so this is my class. Let's say inside my class, I'm writing a function depth database. Okay. And that database will connect with the database, like this method. For now,
Yeah.
I'm just printing the line, like just printing a message, which is connecting to the database. Okay, like for demo, I'm just writing a print message that connecting to the database. Let's say this bank app is like a real application we are creating. This is like a parent class. Bank app is a parent class. And inside bank app, we have this method, which is database, which is taking self as a parameter, which is just no parameter at all, and then connecting to the database. Okay, this is a print message. Now let's say I have another class web bank app. Okay. Now this web bank app will inherit from the bank app. So now this web bank app is a child class. Okay. Now it wanted to, let's say we are putting pass here for now. Same as I'm creating another class, which is mobile bank app. Okay. This is also inherits from the bank app. And then we are also typing pass here. Okay. Now here, think of this one. Bank app is a parent class. It is like my main class here. While web bank app is inherits from the parent class bank app, and mobile is also inherits from the bank app, which is the parent class. So web and mobile, these are the child class. Okay. Now think of, let's say I'm creating a banking application, or let's say you are creating a banking application, and your main class is communicating with the database. Okay, like whatever the information is fetching or putting, the bank app means this one is communicating with the database. Now the same method is used in the web and in the mobile. That is, we are simply assuming. Let's say if I create a object here, let's say object is bank object. Okay, equal, and we are giving here bank app as a class here. Okay, so here we can print or we can call this function. We can call this function which is database here. So we can simply call bank app dot database, right? So this will print. Just a second. So let's save this file. This is advanced underscore oops underscore part underscore part second. Just have it. Let me rename this file. Okay, anyways. So we have this one file, which is now if I run this one, you will notice error. Self, please provide me to that. Yes.
Yes.
Banking database, app database,
Self.
bank app database. It's not asking for the parameter. Okay, anyways, we have this one connecting to the database. So this is simple logic here. We have this one application which is like a parent class, which include a database. Database is a simple method here which is printing this statement. Now I have created two classes which inherits from the bank app. Now let's say you are a senior programmer and I'm a junior programmer. Let's say now I just wanted to use your methods. Like you are a senior programmer and you have created this bank app. Okay, and I'm a junior programmer. Now let's say I have asked you that can I use your database method inside my class? So you said okay, you can use it, but before that you have to implement a security mechanism in your web app, which is here. Same as this another junior programmer, he asked that can I use your database method, which is in this main class. You have said you can use my method, which is database, in your class, but you have to implement a security mechanism because let's say there's no security in the like application, so anyone can hack it. So that is why you are forcing your application, you are forcing your subclass, which is your child class, to implement a additional mechanism which is a security mechanism. Like you're forcing something to your subclasses to add an additional parameter, and that concept is known as abstraction, or we can say abstract method. Okay, let me write it. Okay, then I will explain. Here we have to import from abc. Sorry. So we have to import from abc. From abc, we can import abc, comma, abstract method. Okay, now I have imported two modules here. Okay, like two functions here, abc and abstract method. Okay, now here in the bank app, I just wanted to use abc here, which means now this bank app is also a child class of the abc. Abc is a parent class here. Okay, now what I'm doing, I'm creating a security mechanism. Okay, I'm just creating a security mechanism that is here, def security. This is another function here, like a method here. Okay, and here I'm using self as a parameter, and this will do nothing. For now, it will do nothing here. Okay, it is pass. So now this is a self def security as a method here. Now on top of that, I'm using a abstract method here. Okay, abstract method. Now this security becomes a abstract method. This database is a simple method. Okay, because we don't have an abstract here, but this security is an abstract method here. Okay, now let's say in the web app, I'm writing something. Let's say let's create a function here, def web. Okay, which will take self as a parameter, and here I'm writing print website app. Okay, same as I'm creating another function here inside the mobile app. Okay, basically it is a method again. Okay, and here we have this mobile. And here we have this mobile app. Okay, just a simple function which is printing something. So here we have three classes now. Class 1 is a parent class, but itself is a child class because it inherits from the ABC class. ABC is an abstract class which is in the different file, which we were importing here. Then inside this bank app, we have this database first method. Okay, it is a method here. Then this is the second method, which is security. Now, for now, this security is not a normal method. It is an abstract method because we are using a decorator here. This at the rate abstract method is known as decorator. Okay, what is decorator? We will study later. But for now, it is known as decorator. It is an abstract method which is known as decorator. So this security is not a simple method. It is an abstract method. Okay, why it is an abstract method? Because we are using abstract method, this decorator on top of this function. That is why. Okay, and this method is doing nothing, which is pass here. Then we have one class here, which is a child class, which inherits from the bank app, which is this one. Now this child class can access the database, and this child class, which is web app, can access the security also. Okay, right. But if I run this one, see, if I create a object for web object equal this web bank app. Okay, same as if I create an object for the mobile. Okay, mobile. Now you will see an error here. Okay, see, there's no error, there's no syntax error, but still you will see an error here. Why? See. So the error says can't initiate abstract class bank app without an implementation for the abstract method security. Here we are saying that, as I said, you are the senior programmer and you have said that you can access, you can inherit from my class, which is bank app, but you have to implement a security mechanism. And this is the security mechanism, which means the abstract method is forcing your child class to implement the security method in its own class so that the child class can also implement the security. Okay, this is just a function. I'm just giving an example. Means abstraction is all about. It is forcing you to put some method into the other classes, into the child classes. For example, in this main class, which is bank app, the parent class, in this I'm using a security method here. But in the web bank app, there's no method named security. There's this normal method, which is web here. There's no method of security here. So what I have to do, I have to include another function which is security again. Security. Okay. And this will print here web security, or let's say any code here. Okay. Now the same mechanism I have to apply in the mobile application. Okay, which is mobile security. This is mobile security. Okay, now if I run this one, you will see no error here. No error. Bank app. What's the here? Bank app.
We have to copy. We have to copy this one in the web bank. Teacher the security.
Sorry.
Right. Right.
Just a second. I think
Security.
it's okay. Get this class in a diff, everything is okay. Let me
Mhm.
remove this one for now. Okay, now let's run this one. Okay, now you can see there's no error here. There's no error, which means what is the meaning of this entire code here? This concept first is known as abstraction. Okay, let's read the definition first, then we will understand it. See, a class consists of one or more abstract method is called the abstract class. So this one is my abstract class. Okay, because
Mhm.
here we have this abstract method here. Okay. And why this is abstract method? Because I am saying this is abstract method. I'm using a decorator on top of this particular method, which is security. So it is an abstract method. Okay. And this whole class, bank app, will is a abstract class. Because here I'm including, it contains a abstract method. First. Secondly, abstract methods do not contain their implementation. Okay, abstract class can be inherited by the subclass and abstract method gets its definition in the subclass, which means here you can notice In this is my main application, my banking application, and you have created this application, let's say. And here in this application, you have just created a program or created a method which is security. And here we are not implementing anything in the security. You can see there's nothing. This just pass here. So there's nothing in the security. So the main thing is we are implementing the real security in the subclasses, which is the child classes. They're also known as subclasses. So we are implementing the actual code inside subclasses. This is my code, print web security. It can be any code, it can be any security code, but for now it is an example. So inside security, I'm using the same method at security here, and this is taking web security. Okay, so this is my real implementation. I am implementing the real part in the subclass, not in the main class. Okay, main class, it will always include pass here. But what I'm including in the security is in the subclasses. For example, this is my first subclass, which is a web application. So in this way, I'm implementing a security as a web security. Same as this is my mobile bank app. Inside this one, I have the security here, which is mobile security. Okay, now second definition says abstraction classes are meant to be blueprint of the other classes. Okay, an abstract class can be useful when we are designing large functions, and an abstract class is also helpful to provide the standard interface for different implementation of the components. This line is important because, see, let's say again, let's take a same example. This is my banking application, like my main application here. And a senior programmer has created this application. Now, let's say I'm a junior programmer and I came and I just wanted to implement. My task is to create a banking application on the website. And there's another junior programmer. His task is to create the application, the banking application, this particular application on the mobile app. So that is why I have two classes. Okay, now what is the function of the class? Class is a blueprint, right? And we can inherit from previous classes. We can inherit from the parent class. So bank app is my parent class. Now I this class, which is web bank app. This particular class is inherits from the bank app, which is this class. This class is a parent class, and this class is a child class, which means I am accessing the database, this method and this particular method from the parent class. But as a senior programmer, you have said that you can access my database. Okay, you can access my database class or my method, but you have to implement a security mechanism in your web application and in your mobile application. So you are forcing the junior programmers to implement a security mechanism. Then only that person can use your database. That is why, as a senior programmer, you have implemented an abstract method here, named security here, which means if a junior programmer is implementing a security method here also, then only he or she can access your class. Otherwise, that will throw an error. Same as in the mobile application, you have forced that particular junior programmer to implement a security here also. That is a security here. And when the junior programmer implemented a security method here, then only he or she can access your main class. Okay, your banking app. That is a mechanism here, which means abstraction is forcing to implement any kind of method, which is for in our case it is a security method. So in the main class, which is the bank app, we are not implementing the security. We are implementing the security here in the subclasses. That is the whole mechanism, we can say, of abstraction. Okay, so here you can see a definition here. An abstract-based class is a common application program for the interface of the set of subclasses. It can be used by the third party. Okay, third party is, these are your third party applications. They are using your main class, okay, like bank app here. And now they can access the database because they wanted to connect to the database. They can access your database, but before accessing, they have to implement security. If I remove the security here, see, if I remove the security, it will throw the error. Then this program will not going to run because we are just not using the security here. You can see the error itself says can't initiate abstract class web bank app. We cannot use this initiation class because without an implementation of the abstract method security. This line is important. Like we cannot create this class, or we can create, but we cannot use this class as a parent class because for using this class as a parent class, we have to we have to create another method with the name of security. So this security method will be should be present in the web bank app. Then only this program will run. Otherwise, no. Otherwise, it will not run. So that is like a whole mechanism. Abstraction is forcing the subclasses to put a extra mechanism. In our case, it is a security. Okay, if a junior programmer implement the security here as a method here, then only he or she can use your main class. Okay, then only he or she can use a main class, which is this one. Same as with the mobile app, a person have to create a security here as well. Then only that person can access a parent class. Okay, so this is like the mechanism of abstraction. Abstraction is forcing the subclasses, the child classes, to put the extra features. Okay, like some compulsory features. Without creating these features, you cannot access the parent class. That is known as abstraction. Is it clear?
Yes, teacher.
Okay. And here you can see we are importing ABC. From ABC, we are importing ABC is a module here. And from ABC, we are importing the ABC. Okay, as a class. This is a helper class. And this abstract method is the abstract method under this class. So here we are using ABC here as a parent class. And then here we are creating this particular method as abstract. Let's say I just want the junior programmers, or we can say subclasses, to implement this feature also. Let's say UI interface. Let's say interface size. Let's say pass. So I just want my junior programmers to implement this interface also. Okay, this one is a compulsory method. So for making this compulsory, I can use here as an abstract method here. Okay, this is a decorator here. Now this method is also compulsory. If I run this program, you will see an error here. Okay, error here. You can say can't initiate abstract class web bank app without an implementation of the abstract method interface. So
Mhm.
basically now this class, the parent class, is asking to implement this method also as a compulsory method. Then only we can use the parent class. Okay, which means bank app. So here we have to create another method with the name of the same method interface here. Okay, and here we can use self, and then we can print here web interface. Okay, same as I have to use here. So we can copy this one and paste. This is
Mobile.
mobile interface here. Okay, now we can access. Let's say I just wanted to access the database. See, now this web app, this one, web application can access the database from here. Okay, because this one is the parent class and this one is the child class. Okay, now we can also access the security method here, and we can also access the interface method here. So this will print. One was to database. Okay, now you can see connecting to database, web security, and web interface. Now this web class can access the parent object here, which is parent method here, which is database here. Okay, so this is known as abstract method, or we can say abstraction. And this whole class is known as abstract class. Why? Because here we have multiple abstract method. So this class is known as, we can write here, this
Parent.
class is known as abstract class because it contains one or more abstract method. And which are abstract method? Security and interface. So here you can see we are not really implementing the security. Here we have sparse here. Where are we implementing the security? In the main application, in the subclasses. Here we have this web security, interface security, web interface. Same as in the mobile app. But if I remove the security or interface from here, then my mobile app, this one, cannot access the parent class because it has not implemented the main or compulsory method, which is security or interface. So if I wanted to inherit from the bank app, then I have to, this mobile app has to put the security and interface as its method. Then only we can access. So it is like one parent class is forcing the subclass to put as a compulsory method. Okay. So we can take an example like let's say you are what kind of example we can say? Let's say you are creating an application like let's say a food delivery application. So in that you want the main application is interacting with the let's say with the database or with the server. Okay, now in the main application, which is food delivering application, we have the main implementation, like main database configuration method. And in that main delivery application, you have implemented the abstract method as security, which means you wanted your subclasses to inherit from the bank app, from the delivery app, and it is compulsory to implement security in the website or in the mobile app also, in the food delivery app. So, like the same example, we have to this particular parent class is forcing the subclasses to put this method, which is security, and this interface as a method here. Security and interface here. Then only this particular subclass will run. Otherwise, it will throw the error. Same as we can use here mobile object dot database. And then security, and then interface. And then we can run this connecting the database, mobile security, and mobile interface. So this is like a whole example of an abstract method, or we can say abstract class.
Mm-hmm.
Is it clear, like
Yeah.
the concept?
Yes, teacher. I got it, teacher.
Let me find it. This one is not necessarily clear. Obvious that definition. Okay, so let's say this is another example. So there's some points to remember, which is an abstract class can contain the both method like normal method and abstract method, which is this is my class. This is known as the abstract class. So this class can contain the abstract method, which are these methods, and a normal method. This is a normal method. Okay, without any abstract method. So this is a normal method. So abstract class can contain the normal method as well as abstract method. Okay. Second point is an abstract cannot be initiated. We cannot create object for the abstract class. So here, as I said here, if I wanted to create an object, bank object for this class, which is bank app, this cannot be possible. Means I just wanted to create, this is my class. I just wanted to create the object of this class, bank app. So that is not possible. I cannot create the object. So here you can see this line will throw the error because we cannot create object for the abstract class. So if I run this one, you will see an error here. Okay, the error here. So we cannot create an object for this class, for the main abstract class. And which is the abstract class? This one. So we cannot create an object for this one. But we can create the object for this class and for this class, which we have created here.
Mm-hmm.
Third point is abstraction is essential to hide the core functionality from the users. This point is not important. Yeah. So let's take another example here. Yeah, one more thing is here. See, okay, I will give it an example. See, one more thing is, which I wanted to clear out, that let's say I'm creating a class, a simple class person here. Okay, this is my class, simple person. Inside my class, I have, let's say, some variable here. Okay, some code here. And then I am creating an object for my class. Okay. Now you can see here, this is my simple class. Okay. And inside my class, I have a initializer function. Okay, a method here, which is taking name and age as a parameter and name and age as a like a parameter here. So now I can put here a name, let's say John, and comma age is 15, let's say. Now, previously we have discussed that this P is an object here, right? But P is not actually an object. What is object here? This one. This part is object. This part
Person.
is object. If I run
Mhm.
this code, you will see something. See. Let's print this part. See, I'm not creating an object here. I'm just printing my class. I'm just calling my class. Inside my class, I have this name and age here. If I run this one, you will notice something here. What is this? This is a memory location of where my class object is stored. This is my memory location. Okay, the address here, where my this object is stored. So what is object here? We were discussing previously that P equal person P is object here, but actually P is not object. P here is known as reference variable. Okay, P is known as reference variable. Now, what is reference variable? Let me clear it out. See, if I say that this is my class, which is actually it is a class, and what is the object here? This person is object here. If I am calling this person like this person is my object here, my simple object. Okay, now this object is stored in my memory somewhere else, and this is the location, or we can say the address of of that particular object, where my object is stored in the memory. So this is the address here. Okay, now what we are doing, we are using this one, P equal. So what I'm doing here, I'm just storing my address to this variable. I'm not storing my class. I'm storing my reference address to this variable. That is why this variable is known as reference variable. This particular variable contains my address of my object, where my object is stored in my class, sorry, in my memory. So actually, this is not an object. P is not an object here. P is a reference variable. Okay. Previously, we were discussing that P is object here. We have classes and we have object. This is a class. But what is the object here? Person, simple person, and this parenthesis. It is object. Okay, this is object here. And now we are storing this object inside a variable P. So we are storing the memory address of this P here. Okay, of this P here. Sorry, we are storing the memory address of this person object here inside P. So P is known as a reference variable, not an object. Object is this one, person in parentheses. This is my object. And this object is stored in the memory of my system. Okay, somewhere else. And this is the address. This is the address where this person object is stored in my memory. And what I am doing, I have to access the object. Like I have to access the name and age from my class person, from my object person. So what I'm doing, I'm just storing my address of the object inside this variable P. Okay, if I show you print, see, if I print here ID, okay, ID means it will provide the location ID of class P. Okay, I'm providing the ID. ID will provide you the location. Okay, so you will notice.
Hmm.
You have to provide a arguments here. So now you can see this is the ID, like this is the location where my P object, like P reference variable is stored. And if I show you the ID of, if I show you the ID of this person object, this particular object, so I can put here a parenthesis and ID. Okay, now you will see the same location. Let's see. Okay, they are like same location. You are seeing the same location, 2523 and this one, which means here, this particular class is just a blueprint. Object is the instance of the class. And this person, this one, this part is known as the object. Okay, this part is known as the object. And we are printing the ID, like the address. ID means address. We are just printing the address of that object, like where the object is stored in my memory. Okay, and this is the address here. Okay, this is my address. Now what I am doing, I'm just taking my object and now I'm storing this object inside my P. P is known as a reference variable. It is not an object. Okay, that is what I wanted to clear. P is known as a reference variable. Why? Suppose this is a class. Okay, this is a class. And this is your P here. This person is a class here. Okay, person is a class. Now this is a class, and now you are creating, with the help of this class, you are creating the object of this class. Okay, and what is this object? This part. This part is an object here. Now you are putting this object inside a variable. P. P is a variable here, which means you are just putting the location of this object inside a P. That is why P is known as a reference variable. Okay, so object is like here we have this instance of the class, and this part is known as the object, okay, which is highlighted here. And we are now storing this part inside a variable P, which means we are storing the address. Because if you see this line, we are printing the address of this object, which is this one. And then we are printing the address of the ID P. So the address are same here. The address are same here, which means this P is storing the same part, same address as this one. So overall, we are storing the address inside the P here. So that is why it is known as reference variable. It is not an object. Okay, that is what I wanted to clear. Is it clear? Like
Yes,
kind
teacher.
of. I know this is confusing, but remember, P is known as a reference variable, not an object. This part is a whole object. And inside P, we are storing the address of the object. Okay, which means this is the location. Let's say this is the P, or we can say this is the location. Okay, this is the location. And this is my P here, and this is my object here. P is my variable here, this one. Now P is also targeting this location, and object is also targeting this location. They are like targeting the same location. In this location, I have my class here. That is known as object and reference variable. And this is my class here. And they are targeting to the same location. We have my class stored, okay, in the memory, so that I can
So
access the name and
yeah.
age from the class.
So teacher, the ID here, the print ID, that's the one the locations of this object.
Yeah, it is showing the ID means
Yeah.
address of the
Address, yes.
person, object and P both. And they are same
Yes.
only.
Yes, teacher, I got it.
Okay. So here P is known as a reference variable. Yeah. So now we were discussing the abstraction. Now let's see the different example. Oops. So this is not an important example, but we can consider it. So let's say here is my, we are importing ABC and abstract method again. Okay. And this is my class here. Class car. Car is my class here, which inherits from ABC. ABC is my helper abstract class. Okay. Now here we have this function here, which is mileage. Mileage is a abstract method here because we are using our decorator here, abstract method. Mileage method is an abstract method here. And this method is like kind of compulsory to put in subclasses. Okay, that is why you can see we have subclass here. One class is Tesla. In this Tesla, we have this car here. We inherit from the main class, from the parent class car. And here we have this mileage here as a method here. Okay, this mileage is a method here. Okay, and this mileage